A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. We have seen that the lenses can produce images of different size and nature according to its distance from the object. How are we measuring the distances? Do we need to take any direction for these measurements? There is an internationally accepted system for these measurements. This is called the New Cartesian Sign Convention. These are applicable for both lenses and mirrors. Let's see what are the main points related to the New Cartesian Sign Convention. In experiments related to lenses and mirrors, all the distances are measured in the same manner as in a graph. In a graph, all the distances are measured from the origin. In case of lenses, the optic center is taken as the origin. That is, if we consider a graph, the optic center of the lens will coincide with the origin of the graph. Therefore, all the distances are to be measured from the optic center. As per the convention, the light ray is assumed to travel from left to right. Therefore, all the distances measured along the direction of the incident ray is taken as positive and that in the opposite direction is taken as negative. If we consider this as a graph, the distances measured from the optic center to the right are taken as positive and from the optic center to the left are taken as negative. The distances measured upward from the x-axis are taken as positive and those measured downward are taken as negative. We have seen that the incident ray is always from left to right. Therefore, the rays incident on a convex lens from the left will converge on the principal focus of the right side. So, the focal length is to be measured from the optic center to the right. That's why the focal length of a convex lens is always positive. In case of a concave lens, the rays incident on a concave lens from the left side and will diverge and appear to originate from the principal focus on the left side. So, the focal length is to be measured from the optic center to the left. That's why the focal length of a concave lens is always negative. Let's see an example in this figure given here. You can see a convex lens. An object of height 1 cm is placed at a distance of 25 cm from the lens. Image is formed at a distance of 100 cm from the lens and has a height of 4 cm. Let's apply the sign convention here. Object is placed to the left of the lens. Distances are to be measured from the optic center. Incident ray is from object to the optic center. So, the direction of distance from the lens to the object will be negative. We usually denote the object distance by the letter U. Therefore, U is equal to negative 25 centimeters. The image is formed to the right of the lens. Distances are to be measured from the optic center. From the lens, the image is in the positive direction. That is, the same direction as the incident ray. The image distance is denoted by the letter V. Therefore, V is equal to plus 100 centimeters. Here, the object is placed above the x-axis. Therefore, the height of the object OB is equal to plus 1 centimeters. The image is formed below the x-axis. Therefore, the height of the object is IM, which is equal to negative 4 centimeters. Let's assume the focal length of a lens is 20 centimeters. Since it is a convex lens, the focal length is taken as positive. So, the focal length is positive 20 centimeters. In this figure, U is equal to negative 25 centimeters, V is equal to positive 100 centimeters. Let's now find the value of UV divided by U minus V, which is equal to negative 25 into positive 100 divided by negative 25 minus 100. which is equal to positive 20 centimeters. Here, we are obtained the value of focal length using the image distance and the object distance. But a single analysis will not be sufficient to arrive at a conclusion. Being a science student, we should critically analyze every situation and a conclusion should be made after collecting sufficient data. So, we have to recheck the result by changing the values for u and v. In the first experiment, the values were u is equal to negative 25 centimeters and v is equal to positive 100 centimeters. Now, let's change the values as u is equal to negative 50 centimeters. That is, the object has been moved 25 centimeters away further from the lens. By drawing the ray diagram, we can see that the image is formed at a distance of 25 centimeters from the lens. The image distance is positive. So, v is equal to positive 25 centimeters and u is equal to negative 50 centimeters. So, uv divided by u minus v is equal to negative 50 into 25 divided by negative 50 negative 25. So, which is equal to 20 centimeter again. We got the same value as in the first case. Now, we are placing the object 40 centimeter away from the lens. By drawing the ray diagram, we can see that the image is formed at a distance of 40 centimeters from the lens. The image distance is positive. So, v is equal to 40 centimeters and u is equal to negative 40 centimeters. So, uv divided by u minus v is equal to negative 40 into 40 divided by negative 40 negative 40, which is equal to 20 centimeters. In all the three cases, we got the same value as focal length for uv divided by u minus v. So, we can come to the conclusion that the value of uv divided by u minus v will give the value of focal length for a given lens. That is, there is a relation between the values of object distance, image distance and the focal length. The relation is f is equal to uv divided by u minus v. If we rearrange the terms of this equation, we will get 1 divided by f is equal to 1 divided by v minus 1 divided by u. This is called the lens equation. Lens equation tells us how the object distance and the image distances are related to the focal length of the lens. Look at this problem. When an object is placed at a distance of 50 centimeters from a convex lens, a real image is formed at a distance of 30 centimeters. What is the focal length of the lens? Here, we are given the object is placed at a distance of 15 centimeters from the lens. By applying the sign convention, we get the object distance u is equal to negative 15 centimeters. The image formed here is a real image. We have seen that for a convex lens, all the real images are formed to the right side of the lens. So, the sign of the image distance v is equal to positive 30 centimeters. To find the focal length, we have the relation f is equal to uv divided by u minus v, which is equal to negative 15 into 30 divided by negative 15 negative 30, which is equal to positive 10 centimeters. So, the focal length of this convex lens is found out to be positive 10 centimeters. Let's do another problem. The focal length of a concave lens is 20 centimeters. If an object is kept at a distance of 30 from the lens, find out the distance to the image formed. The lens here is a concave lens. We know that the focal length of a concave lens is negative. So here f is equal to negative 20 centimeters. Object is placed at a distance of 30 centimeters from the lens. By applying the sign convention, we get the object distance u is equal to negative 30 centimeters. We can use the lens formula to find the image distance. We have 1 divided by f is equal to 1 divided by v minus 1 divided by u. That is equal to 1 divided by negative 20 is equal to 1 divided by v minus 1 divided by negative 30. That is 1 by v is equal to 1 divided by negative 20 plus 1 divided by negative 30. That is 1 by v is equal to 1 divided by negative 12. So, v is equal to negative 12 centimeters. That is, the image is formed at a distance of 12 centimeters left to the lens. So, in this session, we have learned how the directions must be chosen while measuring the distances related to lenses, which is the new Cartesian sign convention, and lens formula, which tells us how the object distance and the image distance are related to the focal length of the lens.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS the Learning App.